we have here the inverse property of logarithm, which tells us that if we have the logarithm of a certain expression where we can come up with that expression as an exponentiation having the same base b, okay, it's just equal to the exponent of the said exponentiation. Again, we have here an expression, the logarithm of whatever will be this identity here, but that could be expressed as an exponentiation having the same base of the logarithm. The equivalent of that is the exponent of that said exponentiation. So we're going to show this to be true here. So for this proof, allow me to use this process as I let the left-hand side, the logarithm of this expression, b to the power of k to the base b, equal to any expression, let's say x. And later on, we're going to show that x here is just equal to k to prove this property. Okay? Now, before we go to that, let's not forget that there is a transformation from logarithm or logarithmic equation into an equivalent exponential equation. If we have this form, the logarithm of a to the base b, if this is equal to any variable y, this could be transformed into an exponentiation or exponential equation where we have here base b, the equivalent y would be its exponent, and your a coefficient here is its equality. So this works both ways, from exponential equation to logarithmic equation, and logarithmic equation to this equivalent exponential equation. We are going to use this transformation in our proof in showing that this x here is just equal to the k of this exponentiation. Now, this is what will happen now, as we are going to take this base, just like here, base b, base b. So you have here base b to the power of x as its equivalence, equal to this entire coefficient here, b to the power of k. Now from here, we're just going to use the property of equivalent exponents, which tells us that if we have two exponentiations under equality, and those two exponentiations have the same basis, this will only tell us that the exponents x and k are also just equal to one another, because this is only true if the exponents is also true, given that we have the same basis here. So this time, we have shown that this x, being the value that we have assumed for the logarithm of b to the power of k to the base b, the left-hand side of this rule is just equal to k, which is the intended result of this property. So this proves this property of logarithm. Please take note of this, as this is very important in proving the rest of the rules and properties of logarithms. So this is properties, laws, and theorems. Please subscribe now.